Hello, class. My name is Marlon Glenn. I'm a computer science major here at Virginia State University. And today I'm going to walk you through a program that we made for our final. And it's a query by example content-based imaging retrieval program. So basically, it's a nifty little tool that allows you to select an example image and display the next 20 results that match as closely to the image as possible. So to pull this off, you gotta understand a couple of other concepts first. So our main little magic formula here is called RGB26CC. And basically what it's doing is it's taking the image data from a specified input and it's taking the last two significant bits. And once it does this, it applies a polynomial method to convert it into a grayscale-like format. And by doing this, it creates a normalized sort of format for all of the images that we're going to compare against each other. So here's another function that we want to understand. It's called getHisCounts. And here in this function, we're taking an IMG input, which is equal to a gray level image, and we're taking the number of bins that we want to create. So the number of bins basically relates to the accuracy level of the program based on how many bins are being compared. So say we took 64 bins, for example. This will be on a range of 0 to 63, as our pixel intensity will only be accounted for within that range. So now as we go on through the formula, we can see that we create an open variable that stores one column of values that has the amount of rows equal to the bins that we specified earlier. So next we want to calculate the bin width for each histogram space that we want to calculate. So we take the two range values given that into this input, and then we compare them over the size of the bin value. And then we loop this information back into our bin index. Now, by doing this, we should have the completed kind of comparison for each image in our database. So now, next, and probably most important class that we have to focus on as well is our createDB class. Through this, we create our database that we are going to set the values in our IMCC, our histogram counts. We are going to take these values and put them into this single file. That way that when we have to compare them in our function later in our program, it should have all of the values already loaded and ready to be compared. So by doing this, we want to start off by searching for the file in the import folder. So once we obtain that, we're going to set the length of the data set size equal to the length of the files that we found inside of the file list. So that should equal about 100 in the nature of this program. So by taking this information we create a new object called DB using the same length that we found in dataset size, and we're creating a new object based on the length of that and by the bin count, which is 64 count. So now we process each image that we have in this folder and we read it back into the database, DB. And after we load these values into it, we also want to convert it into a 6-bit histogram value by using the same get hist count formula that we discussed earlier. And by understanding these, be able to apply this to our main function. All right, so here you have your main screen. This contains our import path, which is separated by the file separator operation so that it is compatible amongst all devices, and it is checking for our data and our import folder. And once it finds this target destination, it's going to ask you to include a file name by selecting a picture in the UI. And this JPG tag just means that all of the results are only going to show up in JPG so that you don't confuse yourself with any other files. Once you collect your image, now you're loading it into IMQ, another variable. And then we use this variable to find the 6-bit color code by using the RGB to 6CC formula that we discussed earlier. So back to our main program. Here we have already run the RGB26C code, meaning that our IM6CCQ is holding the color-coded variables for our IMQ image. Find the values for that. We're going to take those color-coded values, and we're going to use our get his counts function, which takes this input, which is basically an image as a grayscale version, and it uses this information to get the histogram data that we're going to compare with that we have in our database. Okay, so now that we've loaded our query image histogram data, that's only one half of the processing that we actually need to do. So now that we have the query image, we also want to do the same for the images stored inside of the database. So we're basically going to repeat these steps that we just did, but with a bunch of other image data. So to start off, we're going to load the database file that we created in create.db, which is stored in the variable db. So after we do that, we're going to create a new empty object by using the zeros command. Now, what we're trying to do here is create a new object that's going to store the Euclidean distances once we compare the distance between the query image and the target image. So the database is pre-registering all of the images and their distances from the query image. So to do this, after we created D, we have to run a for loop inside of it. So we're taking the length of DB, which is also the same length as D, and we're running it from the beginning to the end. And then we extract P from the database variable that we obtained. So this is located here. So by obtaining P, we now compare that with our query target image, and we get the distance between those two, which is also given in our getDistance function, which is also seen right here. We're getting the distance between P and Q, as I said before. So this determines the relation of the similarity between the original image and all of the images that we're sending through the loop. So now that we've completed that, our D should look something like this. Now these are all of the comparisons between the original image and each image in the database, which amounts to 100. Now after we get D, now we want to take what matters the most out of it. So we want to sort it by taking the index of the rows using the sort rows function, and then we take the first 20 indexes and we store it into another variable called top 20. Now this top 20 variable, which is also seen here, holds the index locations for all of the images that are the closest to the variable that we specified in the beginning. So now taking these values, we want to make something meaningful out of it. So how do we do that? We take these images that are referenced by index and we display them, of course. So to do that, we obtain the file list of all of the variables that are currently located in our folder. So this is the file list variable. And this is also shown here, which contains all of the images that are compared with the query image, which also amounts to 100. So now we take this information, create a figure window and a subplot window simultaneously. So first we want to show the query image, which we found in the beginning, which was IMQ. So now that we show IMQ, we want to take the next 20 images that relate to this image query. So to do that, we also make another for loop, taking the information that we got from the top 20, and we want to find every index located in top 20 and store it into file. And as we run through the loop, the target image will be stored in a variable read using this file tag. And we will extract the name from the file tag. And doing this should effectively give you enough information to plot the image on a subplot, which is represented here. Now, by doing this, this should complete the program. So now we just want to take it through a couple of tests, make sure that it's running correctly. So here I've selected an image that has green and yellow as a big part of its image composition. So the program then takes the next few images that also match this description and displays it in order. Try it with another file. Let's go for something different. Oh, got Windows. So yeah, as you can see here, there's the same thing with this target image, and it displays all of the image that are represented as closely to the query image as possible. So now we know it works. All right. So once again, my name is Marlon Glenn. I want to thank you for watching into my presentation, and may you have a wonderful evening.